So this is about building reliable and reusable components, this Learnathon. So we thought it's great to do also a life science track of this Learnathon. And for this, we picked actually a very simple problem, but not so easy to do in KNIME. Our group 2, will be uh, doing a FASTA reader component. And you all know, since you joined the life science group, I assume you all know what a FASTA reader, a FASTA file is, what a FASTA format is, but I will just give you a very brief introduction. Here is some stuff about life science related verified components. We have a lot of components developed in the past year, and we have our own category for life sciences. These are chemistry, chemoinformatics related component, bioinformatics related component. All these components, you will find them under the example server, under components. If you connect to the example server on KNIME Analytics platform, and then if you go to 00 components under life sciences, you will find all these components, and you can drag and drop them to your KNIME workflow. Also, there, you can search them on the KNIME Hub. We decided for this icon for all our life science verified components, and the color is also green for the life science component. So a bit of introduction on FASTA file format. I assume you all know this. Again, it's a very common file format in bioinformatics and in biochemistry. It's a text-based simple file format where you have the IDs to sequences in one line. That starts with this greater than symbol, and then you could have multiple lines following that. That's the sequence itself. It could be a DNA sequence, it could be a protein sequence like shown here on the screen. But how do we read this file actually to do some kind of machine learning or some kind of analysis in KNIME? It doesn't look like the normal CSV files, tabular file formats that we use, like we commonly use with the reader nodes, like the file reader, the CSV reader, where you can just point to the file and then parse it accordingly to have multiple columns and a KNIME table that you can work with for your KNIME workflow. So this is actually how I came up with the idea to create this component. So if you think about it, actually, if you rethink the row and column delimiter, you can actually consider it as a normal something, even if it's not comma separated, but some separated table file. And if you assume the greater than symbol as a row delimiter and the /n symbol as a column delimiter, you can actually parse this file as a table. But you don't want to do this, you don't want to set all the settings all the time, so it makes sense actually to put this string into a component. So the file you see on the left, the black canvas, it can be read using just setting the row delimiter as a greater than symbol and the column delimiter as a column delimiter. And this is what you would see after reading it. So the first column will always contain the sequence ID because we are thinking a row whenever we see greater than, and the others will come up as multiple columns, but we need to format this so that it makes sense because we need to combine all of them into one sequence because one ID corresponds to a sequence. This is what we are going to do today, to create a FASTA reader component that can handle multi-line FASTA files, multi-line FASTA entries, and that can give us also some error messages whenever the file format is not what we expected. So you can download the exercise from the link here, and alternatively, you can search for KNIME Learnathon Group 2 on the Hub, and then you'll find the exercises and the solutions. You can follow me while doing this, while I go through the exercise myself, and you can also do it along, and it's a very simple thing to do. So I encourage you to actually to work this with me on your PC. So that's all for slides. Now I'm going to share my KNIME Analytics platform. This is the solution, and this is the exercise. Okay, here there are some descriptions. You can safely ignore them. So what we are going to do is to create a workflow first that reads a FASTA file, and we visualize also the sequence length distribution. This is a bonus. So reading a FASTA file doesn't include visualizing the sequence length distribution, but we do it for showing off some features of the KNIME visualization capability, and we encapsulate that workflow into a component, and we check the input and write proper error messages. So each of these steps are here represented by a meta node. So the instruction for each steps, you'll find it when you open the meta node. Yeah, so everything you need to do is described here in the annotation inside the meta node. And then once you are done with one of the steps, we'll go back to the main workflow and do the second step, and so on. So here, let me start with step 1. So the instruction says we start by adding a new simple file reader node. This is a new node. It's like the CSV reader, but a bit faster, actually much faster and with more options. So we are asked to use this node. And then what I do is actually use the URL here. So for the configuration, I have embedded a FASTA file within the workflow. It's gzipped thanks to the simple file reader. It can read it directly, but now what I see is actually some Java, some bad stuff. But once I change the column delimiter to /n and the row delimiter to greater than symbol, and what else I should remove has column and header. I think that's it. And support short data rows, because some of the rows, they might not have equal number of lines. So I tick this one, and now actually in the preview, I see that my file being read properly. So it's configured now, I execute it, and I look at the data. It looks like this. The first column contains the ID of the sequences, and the rest of the columns contains the line following that ID. Some of them are just 4 lines, some of them more. And I move on to the second step. Once configured and executed, the simplifier can connect to a column and rename node. So what I do is column rename, and we are going to rename the first column to ID. This is always going to be column 0, so we can rename it to just ID. And then we use a column splitter node and then separate the ID from the rest of the columns. So here, an important thing is we have to make sure we are enforcing inclusion. By enforcing inclusion, we are making sure actually what we are looking for is actually for this specific list of columns here. We don't want the additional columns to be here. So this way, when we have actually more columns, like column 97, they will not be here, but they will stay on the left side. And now we have the ID column on the top split. So now we are going to use a missing value node to replace all string missing values with a fixed value, which is an empty string. This will help us remove the missing values. Oh. Yeah, I have done it vice versa, but this is okay. We can follow the different area, but for the sake of being consistent with the instruction, let me do it as it's supposed to be done. Okay, ID, but if we do this, we have to say enforce inclusion, enforce exclusion, so that we care only about this side of the list. Oh, this was right. Yeah. So here the missing values are gone now. They are replaced with empty strings, so we can concatenate our sequences. And then the next step will be to use a column combiner. And then we combine everything by clicking on enforcing exclusion. So everything will be included, and we name this to sequence. And we choose the replace delimiter by option and use remove include column option. Okay. If I execute this, I should have a single column that's containing the sequences, but I forgot to remove So looks good. We have our sequence as one single column. And then the next step is to use a column expression node to compute the length of the combined sequences. So using this call, and I will add a new column and call it sec length. And it should be a number, an integer, and this is going to be the length of, I can select my column, and I'm done. So now I computed the length of each sequences, and I should have the length column. And now we use a column appender. And get back our ID, our sequence ID. So now we have a 3-column table where we have the ID, where we have the sequences, and where we have their lengths. Now think we have this, and the second step is to visualize the length distribution. For this we need to have a binary node, so histogram node. And this histogram node, I do some configuration. So the histogram column will be this one. Aggregation method is the occurrence count. And under the binning tab, let's fix the number of pins. And I'm going to use 50 pins because this makes sense. And then midpoints is fine. We do this true. And here I make the title sequence length sequence length distribution. And I also should check the x-axis and the y-axis. In the x-axis, we are going to have the length. And in the y-axis, we're going to have frequency. If I execute and open the views, you should see a nice histogram. This is how the length distribution of my sequences looks like. So this is the first part of the exercise. And we are done now. We captured like mostly the logic, most of the logic about how to read the FASTA file and combine the multiple columns, the multiple lines in the FASTA file, and then we were able to visualize it. So this is the workflow, but this took me some time to do, right? So we don't want to do this all the time, so we want to capture this as a component. So the second step is to create a component and customize its interactive view. So the instruction is to encapsulate all the nodes into a component. We can name it a FASTA reader component. And to do that, we just select all the nodes in the workflow, right click on it, and then say create component. And I name this FASTA reader. Yeah. Then I have my component here, but the output port is gone. So another trick would be to add an additional node next to the component, but this is also okay. What we can do is go inside the component or right click on the component, go to setup and add an output port. And this is a data table output port. That's a table output port. So data is the right type. And then we see finish, but now this port is not connected. We have to go back and then connect it from here. Yeah. So if I execute this component, I should see all the sequences as I should see them. Okay, and if I do right click and inspect the view of this component, since we have only one view inside it, it should directly work. But if you want to actually customize, if you had multiple views, if you have multiple visualization nodes within your component, you can use this layouting tool that like Paulo showed, but in our case, that's not necessary. We have a single component and that's shown, a single view that's shown automatically. We don't need to do that. Okay, so the second step is over now. Since we are actually ahead of time, are there any questions that I need to address, Francie?
No, seems to be fine at the moment.
Okay. We are a relatively small group, so everybody can actually ask questions. You can unmute them if they have questions, and we are good on time. Okay, so the third step is to create a configuration option. So here we have a component that reads a particular file from the URL we gave it, but now we want to make sure that anyone can select their own file locally or using a KNIME URL like we did here, using a KNIME relative paths, which is a really nice way also for shipping different examples. And then we want to make sure people can select and control this thing via flow variable, and we want to expose that also as a dialog of the component. And for that, we just finished. We have to go to step 3 and follow the instruction. So we go inside and we are asked to add a local file browser configuration. Let me add that. And we have to go and configure it. I would call the label select a FASTA file, and the description, I will just make it the same. And I will also mention .gz files are allowed. just to inform people that they don't have to unzip their FASTA files. Would save them some disk space. And in the valid extension, we can put in anything we can think of as a valid FASTA extension, FA. So they have to be comma separated. FNA. I think this is fine. And we want it to work right away. And for that, I will use exactly the same URL. That's the KNIME workflow data timeout. I leave it as it is. Okay, since I didn't put the .gz extension in, it's complaining .gz extension for the default file is not okay. Ah, a typo here. And I connect this, so this thing will output a FASTA, like a pass for me. So if you look at the output of this node, the configuration node is right now outputting this passes. And what I want to do is actually here, I want to name this variable FASTA file pass. Because sometimes we might have multiple configurations and you want to tell which is what. And then we can come here and then connect it to where did my dialog went? Okay. So somehow the dialog is open, but oh, it's not. Couldn't find it. So I couldn't find the pop-up dialog here. So I will do it through flow variables for now. I'll go here in the file location and then choose the FASTA file path URL. And now this is controlled via this flow variable. It tells me here the file location is controlled by a variable, still reading the same file. Yeah. So we did the configuration. This is it for our configuration. And now we can close this component and go back, and we can see that our component has a file selection dialog. And now we can browse on our disk to select another files. Another FASTA file, this will work, we can read it, and now it's generic enough to pick any files. Okay, the next step is to the very, this is the very important step to check the input and write proper error messages. This is an essential part of creating a reliable component. Here we have the same component that we did in the last step, but what we want to do is actually when we give it like wrong input files, like we have here, I have some invalid FASTA files. When we give it that, I don't want it to fail with some unknown errors. Yeah, something that says unconnected node column and rename. So people wouldn't understand that. So we want to make sure actually we're gonna have a proper error message whenever we have bad user input. So that's what we're gonna do here. So I want to do all the error handling within a meta node that's called check input. So that's why I created this meta node, and I want to go inside this meta node and finish the error handling process. What I am doing here is actually extracting the table dimension and creating some variables. Those variables include the number of columns and the number of rows I read. And here I have some error messages I want to output, a couple different ones. This is one way of actually creating variables. So here, for example, what kind of error message I will output when the file is empty, the format is bad, or there is no records. Like we have IDs but no sequences in them. So we can change that, we can do that, and we can convert what we have as error message name into a row ID, and then we can use the table to column variable to create a list of variables that we want. So here we have the variable name from the first columns, we have the values from the second one. This is just to show you some tricks. And then from the other one, we are actually using a rule engine when we have one column and one row. So that means actually it's not a FASTA file because we should have some sequence in it. And for that, we are creating actually some variable here that's called not a valid FASTA. And then when the number of rows is 1 and the number of columns are 1, it's set to true. And also again here we have another one column and more than one rows. That means we managed to find some IDs, some sequence IDs, because we have multiple greater than symbols, and that means, but we don't have a second column. That means actually it's not all records are empty. We merge the variables from up and down here. This is already set up for you in the exercise. And now the steps, we will continue with the steps described here. We should connect a breakpoint node to our table we are investigating, and then we make it fail when the table is empty. We take our 4 variables, but we want to make it fail empty when it's empty. So this is empty table, and then we can go here and then say use custom error passage empty file error message. Wait, what's wrong? This is whether to use a custom error message. The custom error message itself is here. Yep. And then we connect a second breakpoint. And in this breakpoint, this should fail when the empty recurse variable is true. So when variable matches value and that variable is empty recurse, and when it is true, we fail, but the custom error message should be empty recurses. Okay, third breakpoint. So the breakpoints, they fail. If they don't fail, they just pass the same input table to the output port. And here, in the same fashion, we can do for not valid FASTA and change the message to invalid FASTA error message. So actually this is an invalid FASTA file. Then, yeah. And then we connect the output here. So when we come out of this, we have our error control logic, our logic for propagating error messages within this component. And this will give us a chance actually to am I using the right step? Yes. So I want to go now, instead of an invalid FASTA, I want to give it the valid one. And when it's valid, every breakpoint will not stop the execution. And it's recommended to make this kind of breakpoints and error checkings as much as possible at the beginning of the component before we do any heavy computation. So we could do this after the column rename or blah, blah, but we want to do it right in the beginning. All right. And another bad practice would be actually using a switch or something, and like a case switch, and then a breakpoint, and then we have a parallel branch going. That's not a very good thing. And having them also in a sequential order makes it easy to see which one failed, and also it will give you a deterministic order of errors. So yeah, you would know actually where it's, and also later when you create test flows or something like that, you would know which error message would come first. Right. So here are some bonus exercises. I wouldn't do them now, but it's already done. You can investigate it for yourself. Here is a way to check if the FASTA file doesn't have a duplicate ID. And the way I did that is we have a duplicate row filter, and then we do a row filter on that. So the duplicate row filter would give us if it's a unique thing, or if it's a unique ID, or if it's not. And then we filter for not unique, for duplicate ones. And this table should be empty. And then we extract the table row variable. So we have here also, we extract the dimension of the table. And then at the end, actually, we create an error message telling us which row ID is actually duplicated. So we are not just saying it's a duplicated thing, but we are also pointing out at which row ID we are having a duplicate element. That will make it easier for people to notice where duplication is. So we do that only for the ID part of the split, and the other continues like this. We have our column appender, and there is the part 2 of the exercise. So the part 2 of the exercise is to check and fail if all sequence lengths are 0. And we can use a row splitter node to separate the row lengths once, and then we can use a breakpoint node to So in the row splitter node, we check for the sequence lengths, and we use a pattern matching, or no, actually we can use a range checking, and we can use 0, 0. So this is the filtered out, and at the top we have the filtered. We have the zero length sequences. We have some sequences actually without any sequence. And then, but what we want to check is actually if we have a zero length, not if we have a zero length. What we want to fail, when we want to fail is when all of them are zero lengths, then it doesn't make sense to read that file. So we take the bottom partition and then check. We will fail if the table is empty. This will make sure actually that not all of our sequences are empty. Yeah, no, no, not this one. So, but we have to again concatenate it. So we did the split and we do a concatenate after the check. I mean, this will change the order a bit, but that's fine. Now this will make it fail. And then we can connect the histogram here, because also creating a histogram for all zero sequences doesn't make any sense here. Okay. Another thing we do here is actually extracting the number of pins, like a valid number of pins, because sometimes like 50, a static number of pins doesn't make sense. So for our histogram, we want to pick the right number of pins. Actually, this kind of brought up by Francie when she was doing the verification of this component. And for some sequences, we have just 2 or 3 of them, and having 50 pins doesn't make sense. So what we are again doing here is we do a duplicate filter on the sequence lengths, or yeah, we can do both because ID is actually anyway unique. It has to be unique. And then we extract the dimension, and then we use a Java snippet node to get the number of pins. Either it has to be 50 or the maximum number of rows, unique lengths we have. And we pass that to the histogram node. And then in this case, it will take either 50, or if it's less than 50 sequences, it will take that number. All right. So now we have a component with error checking embedded in it, and we can try it out using these different files. I added it under the data directory of the workflow. We have invalid FASTA files. When we give it that, we should see a proper error message telling us invalid FASTA files, no records found. And if we change to only ID FASTA files, I probably would make sense actually to show it how these FASTA files look like. But this, you can see them, they are part of the workflow. We have an error message telling table is empty. I think we didn't get the error message set up quite right, but you get the idea. And so we are done with this one. Let me make it back to protein FASTA. Check if it works. It's working. And now we want to add a description. If we are going to share it, if we want to add some documentations for our component and we want to share it on the hub. So the way to do that is to open a component, and then we can add descriptions here. After opening the component, you can use this edit button and then add some description here. And you can add also, you can select the type. I said for life science notes, we use green. This is not inline, but we can use a predictor node, then it becomes green. We can also name the output ports and calling them sequences. And here, yeah, sequence per row, and can save this. And then when we go out and click on our component, we see this description. You can see what's coming out of port 0. You can do this for multiple ports, input ports, output ports. And yeah, another interesting thing I would like to show is here you can control these things like you do for nodes with flow variables. So there was this question about not combining view controls with components. Sometimes what people do is actually place another component with all the configuration in case you want to execute it on the web portal with view controls, and then get all the controls from there and then connect it to this component. We have flow variable. It has like a node, a flow variable ports, and you can connect that and use that to control the dialogues, the options of a component. And now we want to share it on the KNIME Hub. You can share it by clicking on the component and then say share. I'm not connected to the KNIME Hub, that's why I'm not seeing any option. Yeah, now I'm connected. And I can share it in my private space or in the public space. And when I click on share, I'll find the hub. If you want to use it privately, you can use your private space. You can use also a public space. And then in your public space, this will be shared. And you have the decision, you have the choice to make if yeah, the component you created also should be linked to the online version, onto the shared version. If you want to keep developing it, you can say don't create. If you are done developing it, you can create an absolute link, and it will have this green arrow symbol on it. And then whenever there is a new version online, you can do update. You can disconnect the link and then edit it. But as long as sharing goes, as long as it's a shared component, you cannot edit it directly if it's a linked component. And another important thing, when you replace your shared component, don't delete it first and then upload something that will break the link. But what you should do is actually replace it directly. This will not break the link. If you overwrite an existing item like this, it will not break the link of your component. Now, if I go to the hub quickly and search for FASTA reader, there is the official one, but I should also able to see mine here, which was uploaded just today. So by link, I mean this link will not be broken, but this link will be broken if you delete the component and replace it with same name. All right. We are at the last step. So now it's time to use this component. So we have shared it on our public space, and then I can go to a different machine. I can tell my friend to use it. I can also right click on it and see it on the hub. You can say open on the hub, and you can also get a link, but you can also drag and drop it also from the hub like this. So there are multiple ways of using this component. If I drag and drop it, this is the component we just created. It will be here. It will have the configurations, and it can read stuff. Then you are in the KNIME realm. You have your sequences as tables. You can do filtering, for example, for sequences for more than 100 lengths. Thanks to the added column of sequence lengths, you can then see the histogram changing from what we saw before to such a distribution. More things you can do with this is like deep learning. We also have we also released a new component, one-hot encoder. I was actually creating an example. I would like to show you that for one-hot encoder, because people has to see some applications. Why do you do this? So here I have a FASTA reader reading a training data and a one-hot encoder, and then combining these two, I was able to like come from a FASTA file, which the content looks like this, and use a one-hot encoder which can do automatical detection of an alphabet and with different options, and then train a Keras network, a CNN, using these sequences, and was able to classify binding references for this specific protein, RNA binding preferences for this specific protein. And here you can see the performance of this simple model. So it's a simple CNN model, but still doing good. Here you can see the ROC curve, and it's interactive. You can select what's not properly predicted, for example, and then also filter for, here you can say show selected only. And then if I select here, I will see those sequences that are misclassified. You can investigate them, extra. So this is one kind of application that you could use this component for, reading FASTA files by just browsing them and having them as a table, create another component that does something else, and share it with people. So all this trick that took me almost half an hour to do, now you don't have to do it again. You don't have to remember it again. It's captured using this small thing called the component. I think that's it. I don't know how we are on time-wise. Are we early, Francie?
I think we have 10 minutes left now, so.
Okay, so we have to meet. We have to be there 10 minutes before, so that we have a closing remarks. But if you have any questions, any doubts, shoot either in the chat or can they unmute themselves? I will stop sharing. I'm not the best Zoom user. Okay, let me go through You answered all the questions, Franz.
Yeah, there were not that many questions, but there's one now. I'm not sure if they can unmute themselves.
Okay, I really like that idea. I'm doing on have a shared component with my colleagues. So Lars is asking, I really like the idea and I'm doing it on a low level already. I think my main issue is that after I have shared the components with my colleague, they come back to me and tell me it does work with a file, but not file B. CSV XML. When I check that new file, then there is a slight format change. I have to introduce a workaround for that exception. This can easily be an endless loop with including more exceptions. I guess it's important for that approach to always have the same format or it fails. Thanks a lot. Yeah, that's a very valid thing, but still you can include stuff and then they can automatically update it. That's something because if they are using a shared component, not like copy pasting stuff, still you can roll out your updates like that, and at the end it will get better. You have all the format included. That will never happen. But yeah, that's the real world. But as much as possible, I would make my component generic enough so that it can read more.